Okay, so for this project, our group chose mold tools in SOLIDWORKS. And the purpose of mold tools is to create a mold from a part you modeled in SOLIDWORKS. It creates the core and cavity of the mold. The core is the half that has extended surfaces, and the cavity is the half that has depressions in it. So I'm going to go over a basic example that will briefly go over the features of mold tools, and then we'll go over more advanced mold design and dive into some of the more specific features of mold tools and some features that I skipped over in this, that I will skip over in this video. And also, we will go over some solutions to problems you may encounter. So I have a real basic part here, poker chip with a hole in it, and first thing I want to do is get mold tools up in this bar up here. You can do that by right-clicking and selecting mold tools. So what I want to do first is scale the part, because if you pour molten liquid into the mold and then as it cools and hardens, it's going to shrink. So we'll scale it by 2%. Next thing we want to do is create the parting lines. The parting lines lie along the edge of the molded part between the core and cavity surfaces. So the first thing in this, I want to determine the direction of pull, and so I'm going to select this top face right here and run draft analysis by clicking that button. And the part will be highlighted with a bunch of different colors, green being showing positive draft, yellow showing neutral draft, red showing negative draft. And down here, it wants us to select the parting line. So I'm going to select this outer edge right here and click OK. So to cut a tooling block into two pieces, you need two complete surfaces without any holes. So the way we shut off this hole is, or any holes in your part, is by selecting shut off surfaces right up here. And it automatically selects this edge. And so if I click OK, it shuts off that hole. So in order to create a tooling split, we need a parting surface. So we're going to select parting surfaces up here. It automatically selects the parting line we chose last time. And I want the surface to be 3 inches. We'll click OK. And so the next thing we want to do is create the tooling split. So it wants us to create a sketch. And so I'm going to select this top face again. I'm just going to create just a real simple rectangle around the part, but within the surface right here. And you can dimension these if you want. I'll just leave those like that. And we'll exit the sketch. And now you'll have the outline of your mold, your core and cavity. So you can pull these up and down, or you can come in here to the block size and dimension them that way. So I'll click OK, and we see we have our mold. So I'm going to go ahead and hide the surface and just explode this view so that you can see what's on the inside. Okay, there you go. You have your core or your cavity down here and your core up here with your part in the middle.
Now we're going to be looking at a more advanced part. Right off the bat, we can see that our parting surface is not going to be just a simple flat plane. We're going to have our parting surface curve a little bit to get around these little wings right here. Let's go ahead and do a draft analysis from this top plane. And we're going to see something new here, this blue. This blue is called a straddle, and basically what it means is that on this plane, part of it is positive and part of it is negative. To get rid of the blue, we have to click this box that says split faces, and it should automatically split them at the positive and negative draft transition, which means that this line right here marks neutral, we have positive and negative. Next, we're going to pick our parting lines, and the first thing we're going to do is pick all the lines that separate our straddle surfaces. Now, when we break this part in half, we're going to have our parting surface go between this parting line right here and this parting line right here. But how do we do that? What we're going to have to do is actually create some parting lines that aren't going to be used for the split because we don't know exactly where this line is when we exit out of here. So we have to keep them marked. So what we're going to do is we're just going to select these faces right now. And we're going to create two closed loops so that we don't come up with an error. And I will say when you get to these more advanced parts, it's really important to make sure you're selecting all of the lines. That's one of the errors that we really ran into while working on this is because there's so many little lines on these curves, it's really easy to miss a little line like this one right here. So make sure that when you select your parting lines, you are hitting everything. And if you do it correctly and select closed loops, up here we should see a green message that says the parting line is complete. The mold can be separated into core and cavity. However, if we try to use just these parting lines for our parting surface, we're going to run into errors. So what we're going to do is we're going to come and uncheck this box that says use for core cavity split. Now when we do that, we can see these blue lines. The next thing we're going to have to do is a sketch on this surface. And we are just going to take a line and we're going to draw it from this corner to right about here. Then we're also going to do the same thing over on this side. While still in Sketch, if you go back over to Mold Tools, you can't use the Mold Tools, but up here you can see the split line. And that's going to be really important because if we create this sketch and we turn it into a split line, it will cut this part in half and we can use those lines for our parting surfaces. So it automatically selects the current sketch and we just have to select the face, make sure that we're on projection, and call it good. Now we have these lines here. Let's go ahead and do one on this face as well. We'll do a line, make sure that you get it right at this point right here so that we have a solid line all the way across. And we're going to do the same thing over here. And this one I'm just going straight across. We're going to go back to Mold Tools, split line on this one, call it good. Now we still have to get this all the way across because we want lines that go all the way around for our parting surface. So we're going to really quickly do the same thing here. And this one we're just going to bring up a little bit because we're going to have to raise it up some. And now our last one needs to connect these two lines. And there we go. Next, we're going to make another set of parting lines. And it's really important that we check use core and cavity split here because this is what we want for our parting surface. And again, as I mentioned before, it's really important that we select all the lines. The thing that I've found the easiest is start at one location that's easy to identify and just go the entire way around without skipping anything. Because right here, you can't see that we already, if we've selected these or not, because they're already parting lines and they're already blue. So it's really easy to miss these, and we don't want to do that. So now if we've done this correctly, see the fact that it says select edges that form a closed loop means that somewhere in here we do not have all the edges that we need. So what I'm going to do is I'm just going to go back through here and double check these edges. So if I click this over on the left side, right here we can see our parting lines. That took away edge 15. So we need that one on there. That one took away one. So we have edge 14 back. That took away edge 13. And there we go. That right here was the line that I had missed. Now we see the parting line is complete and the mold can be separated into core and cavity. So that's a really big error that you can run into, is that you can miss a single line. Now we're going to make our parting surface. The first thing it asks for is what surface we want the pull from. So we'll click here. We want perpendicular to the pull. And it has already selected this parting line here for us. And if we go ahead and look it over, it does encase the entire part. And so let's just make this a little bit bigger. And right here, you'll see that we can't see the parting line. That's usually just an error in trying to knit the sheets together. So we'll make it a little bit smaller. And right here, we also have what looks like it's folded over. So again, we're going to make this a little bit smaller. And now it looks like we have everything covered. So let's call that parting surface good for now. We'll now do a tooling split. And when you deal with more advanced parts that have a very interesting parting surface like the one we have here, it's really important to make sure that your mold goes all the way around without exceeding the parting surface. So what I'm going to do here is, instead of just drawing a rectangle, I am actually going to draw just a really awkward shape all the way around. And the reason that we're doing that is because it has the sketch that we're drawing here has to be inside of the parting surface but outside the part. And because our parting surface is so short, so that we don't get those errors knitting the sheets together, it has to be that close. So we'll call that good, exit the sketch, and let's go ahead and make sure that this covers the entire part, and it does. And let's see what we got. So the first thing we're going to do is hide our parting surface for now. And we are going to insert an exploded view. We'll drag our top part up. We'll drag our bottom part down. And call that good. And there we have it. We have a mold for our more advanced part. As you can see, the mold itself is very awkward looking, but it accomplishes the job, and that's all that we're looking for right now.
Okay, so the more advanced of a part you try to mold, the more likely you're going to run into errors as you try to create the mold. The first issue that came up with SOLIDWORKS was it crashing or locking up while we were trying to make molds. So we highly recommend saving really often or after every single step when you're working through this. That way you don't lose a bunch of progress you made on your molds. And then the next issue that came up was involving the parting surface. So in order to properly use the tooling split feature, the parting surface right here needs to be larger than the sketch that you end up making for the actual mold that will create your part. Without this, SOLIDWORKS will not allow the tooling split to occur, and it will give you an error message box. So just make sure that this yellow parting surface you create is going to be bigger than the sketch that you make for your mold. Okay, so with this part, the parting surface was placed at the top face of the part right here where these blue lines are at. Those are the parting lines on this one. The issue we ran into with this was that the parting lines did not encompass the features of the part, which in turn resulted in the cavity being completely filled. Because of this, the mold that was created was invalid. So when you make your parting surface and have your parting lines, they need to go around all of these individual little pieces that have those saddle drafts on them in order to be able to create a successful mold. Alright, so our original plan was to model a fan with 6 blades to demonstrate a more advanced mold. However, modeling a very nice looking fancy fan is a little more difficult than it sounds. That could be a video all on its own, honestly. So this is the fan we were working with. It's got a few smaller blades on it than our original plan, and one of the videos we referenced. But our attempt at molding this fan was pretty difficult, so this is what we've got to work with. It's highly recommended that you simplify your part when you go into molding, and since this has that rotational pattern on it, that circular pattern, you can basically cut it into 1/6 to just encompass a couple of the blades, or like 1/2 of the blade and then the other half. So that's what we did with this part in order to simplify it. But the weird thing is, in order to mold one of these advanced geometries, an error actually needs to be created in regards to the parting lines, which you can see right here. We've got that error up there. And the reason for that is because we've got these two saddle surfaces, these saddle draft angles on the edges of the blades, basically meaning we need to create a really complicated parting surface with all the different parting lines. So in order to do that, you have to select these parting lines and then use the 3D spline on surface to create a connecting line in order to kind of close the loop for this parting surface. In theory, SOLIDWORKS should connect these new planes together in order to make a sort of puzzle piece design for the two halves of the mold. However, after 2 weeks of troubleshooting this method, we're still unable to create a successful tooling split. And we don't know if that is something dealing within SOLIDWORKS with it being too complicated of a geometry. It basically tells us that it's unable to mesh knit the surfaces together, meaning it can't complete the loop and create that tooling split. We don't know if we're missing just something small or if it's something deeper within SOLIDWORKS that's causing this error. Some other considerations that you need to consider when you're doing these advanced geometries is that SOLIDWORKS might allow you to create a mold for anything, but not all parts are possible to mold in real life. So you need to really think about how the part will be able to release from the mold after separating the two parts. If there are holes or other geometry that would cause the part to become stuck in one half of the mold, the part will not be a realistic part to be using the modeling the molding techniques with. So just be cautious of what you're modeling and what you're creating a mold for, and make sure that it's something realistic that can actually be released from the mold if you were to create it in real life.